In today's lesson, toda kudzidza this method called completing the square. It is a method used to solve quadratic equations. Saka pakusolva ma-quadratic equations, we mainly have three methods. The easier of the three is the method of factorization. Then we also talk of the method of the quadratic formula. Then we have the method of completing the square. What we should also know is the quadratic formula is actually derived from completing the square. So completing the square is a very important method to master. This technique is used to summarize a quadratic expression and or an equation. So the first note we write is the technique is used to solve a quadratic equation. And I'm sure that by this time we all know what a quadratic equation is, and we all appreciate the form of a quadratic equation, which is ax squared plus bx plus c. As the name implies, completing the square is inspired by perfect squares. Let us write this as a note. Saka completing the square is inspired by perfect squares. And again, what is a perfect square? Tinoziva here kuti perfect square chimbori chi. So a perfect square, an example would be 9, for example. Saka 9 is a perfect square because 3 times 3 gives us 9. 4 is a perfect square, 2 times 2 gives us 4. 16 is a perfect square, 4 times 4 gives us 16. Saka a perfect square, trikutaura tichiti this is a number with an exact square root. This is one way of defining a perfect square. An example would be 9, 16, 4, 25, etc. Saka kana tine number ine an exact square root, kureva kuti square root yacho is going to be a whole number. That number is then a perfect square. This is a generalized definition of it, but it is going to serve the purpose intended of it. In this case, a quadratic expression, cannot equation, is manipulated into a perfect square by considering the following steps in a standard quadratic expression. Saka we are going to use a standard quadratic expression, and the standard cannot general. The standard kana kuti general quadratic expression what is it? It's ax squared plus bx plus c. Tinogona kuwedzera tichiti where a is not equal to 0. So it's important to note that a cannot be 0, because kana a yakava 0, we defeat what a quadratic expression is. We defined a quadratic expression as an expression where the highest order, cannot the highest power of the unknown is 2. Saka kana tisina a yakava 0, 0 kuti takuti 0x squared, knowing kuti any number multiplied by 0 becomes 0. Saka that condition is very important for that expression. Now let us look at what has to be done. Ma steps acho atiri kutaura nezvawo. Let us now complete the square. So let us say we have this is our situation. Tine the expression ax squared plus bx plus c. we want to complete the square for that expression. Then chazokuratidzai kuti munozviita sei when you are doing that for a particular equation. The first step is factoring out the coefficient of the term in degree power 2 with the view of making the coefficient positive 1. Saka we are going to let us write down the steps. Saka step 1, factor out a and it kana chiti a tiri kureva chi coefficient of x squared andika kana kuti the coefficient sekutaura kwakaitwa in our course reader, the coefficient of the term in degree power 2. Saka we have ax squared plus bx plus c. If we factor out a, tetchitichi a andika to a bracket, then x squared plus panapa inova b over a x plus c over a, like that. That's what factoring out looks like. So maybe let me explain what is happening there, and let me use a different color for illustration. Tina ax squared plus bx plus c. We are just dividing everything by a. And because kubuditsa kwatinenge taita a uyu, we are asking ourselves the question, tinoti a times chi kuti tiwane ax squared, tinoti a times x squared, tinoti a times chi kuti tiwane bx. It's a times b over ax kuitira kuti ma a adi in the process anocancelana. The same effect happens with c. So that's of vital importance. And it. So what happens after we have done this? Tinozita say kanatada is so. Our step number 2. In our step 2, we are going to add and immediately subtract the square of half the coefficient of the term in x. So this is one of the most important parts. For step number 2, we are going to add and immediately subtract half the coefficient of the term in x. And what exactly do we mean by this? Sakatatuane a situation of a factored out. So a, then the brackets x squared plus b over ax plus c over a. Then what we do is tishatora a-ish, and then it becomes x squared plus b over a x and tova 30 plus immediately sakapa 30 we add immediately and satishava 30 plus b over 2a, but that should be squared. Then we immediately subtract minus b over 2a, that's squared, plus c over a, like this. Saka chichaitika panapa. Saka we have yatingati a zero effect. Effect yacho inobva pakuti tika adda chinhu to an equation and then we immediately subtract, tinenge tisina kuchinja the intrinsic value of that equation. Like if you have the equation x plus 2, for example, take at x plus 2, then we add 1 plus 1, then we immediately subtract 1 yacho yoyo. Hatina kuchinja value ya equation yacho. Saka the value of that equation haina kutombochinja. Nekuti chata adda chiri foreign, which is half of the coefficient of the term in x squared. Panapa nachifanga kuwedzera kuti squared. Ta adda tikatoita chi immediately subtract. And the reason why we do this takes us directly to step number 3, where expressing the first and third terms as a factor summarizes the first 3 terms into a perfect square. The last 2 terms remain the same. So let us put it down as is. So panapa, what we are going to do is we are going to express the first and third terms as a factor. And what does this do? It summarizes the first 3 terms into a perfect square. Saka tokunoti that is summarizing the first 3 terms into a perfect square. Then the last 2 terms remain as is. And let us illustrate what is happening here. Saka patanga tine this situation, let me rewrite it. Tanga tina a yanga. Then panapa it was x squared plus b over a x. Then tavata add half of the coefficient of x. Saka coefficient ya x ndi b over a. Kureva kuti tichati half times b over a, which is b over 2a. But half of the coefficient of x should be squared. Then we immediately subtract b over 2a squared like that. Then theta immediately subtract. Then it's just going to be plus c over a. Step 3, which we have to express the first and third terms as a factor. What is the effect of this? Summarizing the first 3 terms into a perfect square. It simply means a, like this, and tunobva tati x plus b over 2a squared. Saka the first 3 terms ndodzata kusummarize as x plus b over 2a squared. Then materms aya ekupedzisira aya angodzoka kadaro minus b over 2a squared plus c over a. So the first 3 terms, x squared plus b over a, x plus b over 2a squared, ndo yata kureduce kana kusummarize as x plus b over 2a everything squared. So kutoti muka manipulate kana kuexpanda this bracket x plus b over 2a squared, it's automatically going to give you x squared plus b over a, x plus b over 2a squared. That is what it's going to give you. Okay. Saka we can further manipulate that in a, and then it's x plus b over 2a squared, like that. It's minus b squared over 4a squared. That was what the laws of indices, b over 2a squared in get equal to b squared over 2a, like everything squared, giving us b squared over 4a squared. Then up it's plus c over a, like this. After having done this, extending the effect of the overall multiplier to all the terms inside the major pair of brackets. So our step 4, what are we going to do for our step 4? Step 4, we are going to multiply everything, every term by a. Kurot a itakuipinza mukatu. Saka inozobudaya kata say inenge chibudaya yakati a x plus b over 2a squared yobva yati minus b squared over 4a, and then plus c, something like this. So what we have to note is, once the quadratic expression has been successfully summarized, one can easily determine the coordinates at a turning point, whether their maximum or their minimum. The x value is given by equating the value inside the pair of brackets to 0, and the corresponding y value is the part free of the brackets. Okay, saka chiri kutaura panapa ndechipi? Ndechekuti kana tiine this conclusion yatava nayo, a then bracket of x plus b over 2a, everything bracketed and squared, minus b squared over 4a plus c. That is what we have. Tiri kuti the coordinates at a turning point what are they? Ticha equator zviri mukati mebracket munomu to 0 kuti tiwane the x value. Muri kuzviona? Saka ndogona kuti for the x value tichatora zviri mukati mebracket toti it's equal to 0. Saka x plus b over 2a is equal to 0. Ndokuti tiwane the x value. Mazvona? Then kana takuda the y value, so for the y value zvese zviri kunze ndo y value. Saka y value yedu inenge iri, tikada kuinyoramo properly, inenge iri c minus b squared over 4a. Andika? Saka the coordinates eventually anozobuda ari chi, because if we take x plus b over 2a toti it's equal to 0, zvinoreva izvo kuti x inenge iri equal to chi minus b over 2a. Saka ma coordinates edu takumanyora in coordinate form anenge achiti minus b over 2a, and for y anenge achiti c minus b squared over 4a. Saka iyi ndiyo nzira yekuwana nayo ma coordinates. Chakudzidzisai imwe nzira yekudifferentiate pachaita calculus, but this is the way you find the coordinates of the turning point. Saka patikaita curve sketching, we learned about how to use the discriminant of a quadratic equation. Discriminant inoshanda pachi to determine the nature of the roots. Do we have two distinct roots? Do we have a repeated root? Do we have non-existing kana kuti no real roots? Takadzidza about using a to determine the nature of the turning point. Kana a ari positive, that is greater than 0, tine a minimum turning point. Kana a ari negative, that is a ari less than 0, tine a maximum turning point. Chinhu chatadzidza nhasi chino contribute directly to curve sketching are the coordinates of those turning points, which are going to be given by minus b over 2a ndiyo x value, then c minus b squared over 4a ndiyo y value. Let us go through examples. We have 3 examples we want to work through, but in these particular examples ndoda kutanga ndadzokorodza the whole process of completing the square. But in this case ndiri kuda kuti process iyi tiite tichiderive the quadratic formula. Mazvona? Saka we want to derive the quadratic formula. Saka deriving the quadratic formula. That is what we want to do. Kuderive quadratic formula zvatinokuita, tina ax squared plus bx plus c, but this time it's an equation, so it's equal to 0. Then tadai so we are going to factor out a, kureva kuti inchava a x squared plus b over a x plus c over a is equal to 0. Then what we do is ticha multiply ku left hand side na 1 over a, roti ma a akanzelane, ticha multiply kuno kuna 1 over a. Effective multiply any number by 0 gives us 0. Saka panapa we have x squared plus b over a x plus c over a is equal to 0. Remember kwatiri kuda kuenda, the end result yatiri kuda, it's this: x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This is what we get. Ndo kwatiri kuda kuenda. Saka in other terms, we want to make x the subject of formula. Sata panapa takuchenda ku that stage yekuti we are going to immediately add half the coefficient of x squared, then immediately subtract it. Saka inge yakuti chin x squared plus b over ax, then plus half of the coefficient of x and b over 2a, and squared subtracting g b over 2a squared, we add and immediately subtract, plus c over a is equal to 0. Then we summarize the first three terms. Anova buda akadai so: x plus b over 2a squared, then kunoku yongodzoka iri minus b over 2a squared plus c over a. This is equal to 0. Saka yadai so, let us simplify it. Ichabva yavachi x plus b over 2a squared, then it's minus b squared over 4a squared, then panapa it's plus c over a. This is equal to 0. Then swadaro manje tinobva taita sei, tinobva taendesa izvi ku this side, tosara tina x plus b over 2a squared is equal to, panapa ichavachi b squared over 4a squared plus, it's not plus, inova minus rather, minus c over a. Saka panapa chati x plus b over 2a squared is equal to, panapa our common denominator is obviously 4a squared. 4a squared into 4a squared into 1. 1 times b squared, that's b squared, subtracting a into 4a squared into 4a times a, that's 4ac. So as you can see, tatuani a discriminant already. Then we take the square root of both sides. Kunoku we want to clear the square, but since tatora ta introduce a square root kunoku, we are going to do the same kunoku like that. So kunoku chasara tina x plus b over 2a is equal to, kunoku ichava the square root of b squared minus 4ac over the square root of 4a squared. Then yadaro manje inenge yakuti x plus b over 2a is equal to, then panapa remember what kana chitora the square root of a number, cannot a term, it's plus or minus, so it's plus or minus the square root of b squared minus 4ac over square root ya 4a squared in the 2a. We take the square root of 4, the 2, the square root of a squared in the a. Saka pano ichava x plus, cannot x is equal to tot minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Saka x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Zvataita izvi zvinotibatsira pakusolva ma-quadratic equations tichishandisa completing the square. Saka maona kuti that is how we derive the quadratic formula using the method of completing the square. In the examples we want to do, Maquestions edu ari kufunza the coordinates of the turning point. Saka we want to find the coordinates of the turning point. How do we find that? Let us go to our first question. Question number 1, iri kuti if the function of x and it is equal to 2x squared minus 12x plus 13, find coordinates of turning point. Find the coordinates of the turning point. How are we going to find them? We are going to use the method of completing the square. Sekutaro kwandaita, you can use the method of differentiation, but that's calculus. We haven't done it yet. So how are we going to use this method of completing the square? Tichada is so the function of x is equal to 2x squared minus 12x plus 13. And it then to that, this obviously is going to be equal to, teacher factor out the coefficient of x, saka 2, then over x squared, up which over minus 6x, up over plus 13 over 2. Saka tika factor out 2, tunosara ni situation yotu mkati mema brackets, muna x squared minus 6x plus 13 over 2. Then we are going to immediately add, then immediately subtract half of the coefficient of x squared. So it's actually going to be equal to 2. So it's x squared and it to that minus 6x. Then we add half of the coefficient of x squared, immediately subtract half of the coefficient of x squared. Then it's plus 13 over 2, like this. So this is equal to 2 and it x squared minus 6x. Then up it's actually going to be equal to so tinoti, what can we do up? It's plus minus 3 squared to subtract minus 3 squared, because I'm going to 2 into minus 6 plus 13 over 2, like that. Then tadaro manje, what are we going to do next? This is equal to 2 and it can. Then we are going to summarize the first 3 terms. We are going to summarize the first 3 terms into a situation like this. Each hour x minus 3 squared, like that. Then panapa inobva yavachi minus 3 squared, that's 9, saka it's minus 9 plus 13 over 2, like this. Saka kana tadaiso manje zvoreva kuti takuchi multiplier 2 into that situation, kureva kuti ichava 2 bracket of x minus 3 squared yobva yava minus 18 plus 13, like that. Anditika. Then yadaiso manje tinenge takudaiso. So this is equal to 2x minus 3 squared minus 18 plus 13, answer yedu ndi minus 5. Saka eventually tikuwana the function of x iri equal to 2, then x minus 3 squared minus 5. Now kana takuda the coordinates of the turning point. Saka coordinates of turning point anenge ari equal to chi. Remember that for the x and for the x coordinate tichatora zviri mukati mebracket tozviikweta kuna 0. Saka for the x coordinate tichatora zviri mukati mebracket which is x minus 3 toti it's equal to 0, kureva kuti x inenge iri equal to chi to 3. then for the y coordinate tichatora zviri kunze kureva kuti y inge richi -5 zvinge zvatopera zvakadai so that is how it's done. If you have problems, questions, don't hesitate to ask. We will try to proffer the solutions. Let us go to our second practice question. Second practice question yedu iri kuti if the function of x is equal to 2x squared minus 12x plus 7, find coordinates of turning point. Saka coordinates of turning point panapa, the function of x is 2x squared minus 12x plus 7. That is the function of x. What are we going to do? Ticha factor out 2 kuti sare richi iri x squared minus, then it's minus 6x plus 7 over 2. Then tadai, so we are going to add and immediately subtract half of the coefficient of x squared. Then get it 2x squared minus 6x yobva yatichi we add, so it's plus minus 6 over 2 squared minus 6 over 2 squared, then panapa it's plus 7 over 2, like this. So this then is equal to teta kuti 200 sapanapa tachifanga kudai, so I'm sorry kuratidza kuti 2 iri kumultiply everything. Saka tinenge takuti 2, let me do this, this is equal to tinenge takuti 2 todai, so the first 3 terms toma summarize as x, then 2 into minus 6 into minus 3, so it's x minus 3 squared, like that. And it then up yowachi minus 2 into minus 6 into minus 3 squared into 9, and it tovatati plus 7 over 2, like this. Saka chateta hapa ndichekuti we have just summarized the first 3 terms tovata simplify the other terms. Then panapa 2 yakumultiply chipinda mukatumu kureva kuti chava 2, then x minus 3 squared, 2 times minus 9, that's minus 18, and 2 times 7 over 2, that's plus 7, like that. Kureva this is actually equal to 2 x minus 3 squared, then minus 18 plus 7, answer yedu minus 11. Therefore, coordinates of turning point anenge ari equal to chi. X coordinate tinotora zviri mukati mebracket toti equal to 0, kureva kuti x ichava equal to 3. Y coordinate tinotora zvinenge zviri kunze kunoku, saka inenge iri minus 11, like this. So this is not rocket science, amadzangu. It's quite easy. It's quite easy to do. Let us go to our third practice question. Third practice question yedu iri kuti if h of x and it is equal to 6x minus x squared, find coordinates of TP. Find the coordinates of the turning point. Okay, saka how do we find the coordinates of the turning point? Panapa chekutanga ngatiti hx is equal to minus x squared plus 6x. Tokuzvitira for the sake of convenience. We factor out the coefficient of x squared, kurotka cha factor out minus 1. Panapa ichangova x squared, then apo ichavachi minus 6x, like this. Then tada iso manje tichati this is equal to minus 1, and it yata factor out hiyo tovata add and immediately subtract the coefficient of x squared. Saka inge irichi x squared minus 6x toti plus minus 6 over 2 squared minus 6 over 2 squared, then uku it's plus 0 because hatina c, saka inongosara yakadai so. Then panapa this is going to be equal to minus 1. We summarize the first three terms kuti idai so ive x, then 2 into 2 1, 2 into 6, then 2 into minus 6 and minus 3, saka it's actually x minus 3 squared, then up inge minus 3 squared and 9, saka it's minus 9 like this. Then we are going to multiply minus 1 into inside the bracket kuroti chava minus x minus 3 squared plus 9. Therefore the coordinates of the turning point are equal to, we take what is inside the bracket, equate it to 0, kureva kuti inge 3 apa, kureva kuti tichangotora zviri mukati mebracket, then we negate it, then our y value inge 9. Tikadai so tinenge tatopedza. So this is the sum of what we wanted to learn, brethren. This is the sum of what we wanted to learn. Let us say you have questions. You can reach us on this number. Kana muri muZimbabwe, it's just 0715213310. Thank you and have a nice one.